Okay, let's get going here. We're going to talk about the next part here, parallel lines, and today you will use theorems to determine the relationship between specific pairs of angles. Today you will use algebra to find angle measurements, and hopefully today you will prove lines are parallel, or we'll see different ways that we can prove lines are parallel. Anyways, so let's look at the first part. Let me start off here. Let me back up a little bit here. Okay, so here's our first postulate. First postulate says if two lines are parallel, it's called the corresponding angles postulate. Two lines are cut by transversal. Two parallel lines are cut by transversal. Then each pair of corresponding angles is congruent. Now notice there that they're talking about corresponding angles and they're only talking a pair. So you got to look at two at a time. So kind of keep that in mind. So let's look at this. Here's an example. Now keep in mind, when you see those little arrows on a line, that means those two lines are parallel. Okay? Now I'm going to cut a transversal through that, and then I'm going to label some different angles. Okay, so I have like angle 1. Angle 1 is corresponding. Now what does it mean to be corresponding? Corresponding angles are like the ones that are like across. So like from say here to here or here to here, like that. They're not right next to each other, but they're kind of across. Okay, so we can say that angle 1 is congruent to angle 3 because this little postulate is telling me that those corresponding angles are congruent because I'm saying 1 and 3 are congruent. They're corresponding, so they must be congruent by this postulate. Then that means angle 2 and angle 4 must be congruent. And angle 8 and 6 must be congruent. And 7 and 5 must be congruent. So again, notice there we are talking about what those are. Corresponding angles, again, are the ones that are across. And don't forget, these like this, those are called linear pairs. That means they're supplemental. So if they're right next to each other on a straight line, those are linear pairs. Gotta know your vocabulary, kiddos. So let's look at an example. So given, I'm going to give you that measurement of angle 2 is 75 degrees. Then find the measurements of all the other angles. Okay, so we're going to find the measurements of all the other angles. So if 2 is 75, then right across from it is 6, which is also 75. Now, we should also remember from the previous chapter, vertical angles, or actually I think the previous section, vertical angles, those that are right across from each other like that, like where I'm showing 2, 4, they're also congruent. So 4 is 75. And if 4 is 75, then its corresponding angle of 8, angle 8, is also going to be 75. So I could either say it was based on the vertical with 6, or the fact that 4 and 8 are corresponding angles. Now, how would I find 1, 3, 5, and 7? Well, don't forget, 1 and 2 are supplemental. They're linear pair because they're on a straight line and they're being cut by another line. So that means that they add up to 180. So I can take the 180 and subtract 75, and I will get 105, which will tell me what angle 1 is. And then by definition, angle 5 is, or postulate 3.1, is 105. And we can also say that angle 1 and angle 3 are vertical angles, so that's 105. And then angle 7 is corresponding to 3, so that one's 105. So there you go. Very quickly and fairly easily, you got all those different answers. Alright, so you need to know these theorems. And again, remember, these are theorems that we can use to prove things. But we have the alternate interior angles theorem, which says if two parallel lines are cut by transversal, then each pair of alternate interior angles is congruent. So notice here, like we're not just going like say from here to here, but now we're talking about alternate interior angles and saying those are congruent. Okay, so kind of keep that in mind. Consecutive interior angles, theorem 3.2. If two parallel lines are cut by transversal, then each pair of consecutive interior angles is supplementary. So like 1 and 2 add up to 180. 4 and 3 add up to 180 because they're right next to each other and they're interior. Like the two interior angles, that's consecutive interior. Okay. Alternate interior angles. Theorem. If two parallel lines are cut by transversal, then each pair of alternate exterior angles is congruent. So alternate exterior angles. So like 5 is 5 and 7 are alternate exteriors, 6 and 8 are alternate exteriors, and they would add up to, they would be congruent. Now, notice, this is backed up with what you've got here in this picture. So kind of keep that in mind. Whoops, went too far. Let's go back here. All right, so here we go. You're going to be given measurement of angle 1 is 3x plus 5. Measurement of angle 2 is 4x minus 5. And 3x plus 15. And the measurement of angle 3 is 5y. Now, they're going to say, let's find x and y. And then in theory, you could find all the other angles if you wanted. But let's go ahead and find x and y. So, because 1 and 2 are corresponding angles, I can say that, and don't forget, P and Q are parallel, and so is R and S. That's what those little arrows mean. Notice that P and Q have double arrows, and R and S have just a single arrow. So that's saying P and Q are only parallel to each other, and R and S are only parallel to each other. Okay, so notice 1 and 2 are corresponding angles, so that means that they're congruent, or they're equal. So I can say 3x plus 15 equals 4x minus 5. And then I'm going to say, like I always say, variables to the left, numbers to the right. So I've got 3x minus 4x, which is negative 1x, and then negative 5 minus 15 is negative 20. If you divide by negative 1, you would get x equals 20, and you are done with that part. Now I got to find y. Well, I also know that 2 and 3 are corresponding angles, so I could do that and say angle 2 is equal to, say, 4x minus 5, which is equal to measurement of angle 3, which is 5y. That doesn't help me because I have an x and y, but I do now know that x is equal to 20. So I can say 4 times 20, which is 80, minus 5 is 75, and then I can divide by 5 to get 15. So y is 15. All right, and that's that for that section. I'll do the proving parallel lines as a separate set of notes because I don't want to go too long. So we will come to that third objective that we talked about later. It'll be on the next set of notes. Anyways, that's it for today. Thank you so much for your time. Y'all take care. Y'all are doing great.